Hello guys, welcome back to my channel Code with Med. So today we are going to learn about central processing unit, right? Today we are going to learn about central processing unit. So in operating system, central we need to learn about the central processing unit as all the subject is revolving around the processes and the managing of processors uh, and all, right? So, central processing unit is the brain of a computer, right? Because it is the only thing that can execute any the instructions. Like as you have already, as you know, there is a control unit in it. There is a arithmetic logic unit in it, which performs the logical task, which performs the logical task, right? So, CPU is the brain of the computer, which needs to access the memory, which needs to access the memory to get the instruction which needs to be executed, right? And then performs the execution on it, right? Now, let me tell you something about memory. There are four kinds of memory which are in terms of the fastness, right? On the topmost layer, there are registers. There are registers, right? Then comes the cache, right? It is less faster than the registers. Then comes main memory, right? And then comes secondary memory, right? Disk. Okay, so registers are so fast because it is made up of the same material that the CPU is made up of. So there is no delay in accessing the data from the registers, right? Okay, so for CPU to execute any instruction, there are some registers. There are some registers that CPU holds, right? Let me tell you some of some of them. Firstly, they are general purpose registers. General purpose registers. So these registers stores the value of temporary variables and key variables, which is required for the execution of the particular instruction that it is executing. Right? Then comes a special register called program counter. Program counter. What does the program counter do? It points to the memory location of the next instruction that is needed to be executed, right? It points to the memory location. It points to memory location of the next instruction that is needed to be executed after the execution of the particular instruction that is being executed right, that is being executing right now, right? Suppose there is a process which is executing right now. Okay, so the next process which is being executed will be pointed by the program counter. Okay. Hmm. And the next register is the stack pointer, right? Stack pointer. So what it is pointing to? It is pointing to the top of the stack, right? It is pointing to the top of the stack in the memory, right? Um, Let us suppose that there is a program, right? Let us suppose there is a program, and you call a function foo, and it again calls a function cal, and it again calls a function yo, right? So currently you are firstly there is a main function, right? Which is being handled by main function where the operating system comes first for C++, right? Then after executing main, it comes to foo, and then it comes to cal, and then it comes to yo. So currently we are executing yo. So the stack pointer will point to this particular function, right? This location of the memory address of this particular function. Function parameters also have addresses, right? So the stack pointer points to this particular address, right? Okay. Then in this stack pointer, firstly, as soon as the yo get finished, the stack pointer will point to cal. Then the stack pointer will point to foo, right? So this is in the form of stack. That's why stack pointer. Now the other register that CPU holds uh, is a PSW, program status word. Okay, PS okay, PSW, program status word. So what does it contain? It contains very important instructions which is required for time-based resource sharing. Right? As we have discussed, there are modes of resource sharing. Firstly space, and the second is time. Right? So for the time-based resource sharing, this register contains instruction important for that. What some of those instructions are like? Um, some of those instructions are like in which mode it is executing. Right? Is it executing in user mode or kernel mode? Okay, user mode or kernel mode. Secondly, it holds the priority it holds the priority of the currently executing instruction, right? And contains it also contains a control bits, control bits. Okay, so these instructions are important for time-based resource sharing, right? So um, now let us suppose a process is being executed in user mode. Let us suppose, as we know that in user mode there is no allowance for the process to access the hardware or input device or memory, right? So access, to access, um, to get the access, like let us suppose during its execution it requires some input output devices, right? So what it will be doing, it will be generating a system call, which this system call will generate a trap, okay, which will be handled by operating system, and thereby control goes from user mode to kernel mode. And now operating system then handle how to resolve this trap, how to fix this trap, or how to manage this trap, and then it covers the requirement of this program which was executing in user mode and requires some execution by the operating system. So system calls works in this way. We will talk further about the system call later in our videos. Okay. Now, let me tell you one thing that central processing unit, central processing unit contains some portions. Three of them are fetch unit, decode unit, execute unit, right? In this, like whenever a CPU wants to execute a particular instruction, what is needed to be done? Like it's obvious that it won't be getting instruction on its own. It needs to fetch it first from the memory, right? And then needs to decode it, that what this instruction needed to be uh, doing, right? And then after decoding it, executing the particular instruction, that what like whatever this function want, whatever this process want, I need to execute it. Central processing unit, CPU or processor, does this. So three um, there are three portions of the CPU, right? If let us suppose if there is a one program, one process, it first fetches the instruction and then decode and then execute it, right? So let us suppose that it is in decoding part. Then the fetching unit will be empty, like it won't be doing anything, right? CPU is just decoding, and the fetch unit is not working, right? So this is getting wasted, right? Now this can happen. This can happen that at a particular instance, the fetching unit is fetching other process, decoding other process, and executing other process. And this is known as pipelining. This is known as pipelining, right? At a particular instance, it is fetching other process, decoding other process, and executing other process rather than fetching, decoding, and executing a single process. Okay, this is known as pipelining. Yeah. So that's all for this video. Thank you guys, and keep watching my videos, and do like if you like the video, subscribe our channel, and comment if you're having any doubt. Thanks.